Good afternoon. So, where were we? Kindly open your registers and let me know where you were. Throughput, turnaround, throughput. In between, it was wait time also. Turnaround time, wait time, and then throughput. Next, write down is response time. From the time of submission of request until first response is produced. I repeat, from the time of submission of request until first response is produced. You can take the screenshot. We will be doing these ones also. Fairness, priorities, predictability, CPU's utilization, etc. etc. Okay, one by one we will discuss. Mostly you are only asked to calculate up to response time. So, in fairness, it will be the degree to which all processes are given equal opportunity to execute. Degree to which all processors degree to which all processes are given equal opportunity to execute. I try to be fair with everyone. I try not to do partiality. This is what is expected out of every system existing in this universe. The computers have also been tried to make on that basis. An algorithm should go in for fairness unless until there is priority given, which is the next topic. So, equal time should be given. There are criterias which we are discussing, based on which we will be seeing there are some schedulings which give preference to which process. The scheduling criteria, their algorithm is designed in such a way you will be able to see the difference yourself. But talking about these things, what is fairness? That there is no process which is made to suffer from starvation. The first line I made you write is degree to which all processes are given equal opportunity to execute. Okay, how much all the processes are given a chance to execute properly. Next line, does not allow a process to suffer from starvation. Do not allow a process to suffer from starvation. What is starvation? Yes, you heard it right. It's the English word starvation. You're starving, means you're not getting anything to eat. In the terms of computer science, here, processes starvation means that they are made to wait and wait. It is getting stuck in the scheduling queue forever, indefinitely, and it is not getting the processor for execution. So, if you want to write, you can write the definition of starvation. A process left out unfinished. Very good. बट किस लिए? बिकॉज उसको मिल ही नहीं रहा. ये थोड़ी ना है कि सिस्टम में प्रोसेसेस को एग्जीक्यूट करने के लिए प्रोसेसर नहीं है. दूसरे प्रोसेसेस को ज़्यादा प्रायोरिटी दी जा रही है, उनके साथ पार्शियलिटी करी जा रही है और उनको कहा जा रहा है कि आप ही करते रहो. इस तरह से इट इज़ नॉट फेयर. या अदर प्रोसेसेस इन क्यू. सो यू कैन राइट a process is a victim of starvation if it gets stuck in the scheduling queues indefinitely. Next point is priorities. Point number 5, that, as the name suggests, giving preferential treatment to processes with higher priorities. There are situations in which priorities have to be given, like real time systems. So here you can write the line, give preferential treatment to processes with higher priority. Next is predictability. As I shared the screen, you would have noted. What you will consider more appropriate? A system having mostly 1 second to response, but sometimes take 10 seconds, or another one which is, say, consistently responding in 2 seconds. The book says the one which is responding every time in 2 seconds. We know that in this much time, we are definitely going to get the response. Like in metro, you know the time is fixed. Within this much time, you will reach from one station to another. The day there occurs some delay or there is problem in the line, there is so much frustration. But the one which is always on time is something you prefer. The buses get delayed, coming to college by bus is not preferred by you. You prefer consistency, that it is known whether be it bad weather or any other problem, 99% of times metro will take us on time. So users prefer consistency. The system which was the first one is viewed as a more negative one than the one that consistently responds in 2 seconds. Okay? I'm happy that you are responding. At least one person is listening. That is what I can understand. And I'm so happy for that. All others are busy somewhere, I don't know where. So, last is CPU utilization. Obviously, the more it is utilized during the time, the better it is. So, this was about the scheduling criteria, out of which numericals will be based on first four and not the last four. One more thing before we start the numericals, there are two types of scheduling algorithms. Next topic is scheduling algorithms. I will say the word, but you will not be able to comprehend that well. So, for a few moments, I'll share again. These are preemptive and non preemptive algorithms. The names are preemptive algorithm, non preemptive algorithm. Preemptive are also called as cooperating, and non preemptive will be which ones? Non cooperative. Good, Aditya. Sometimes there is misprint in the question paper about the spellings of preemptive and non preemptive. So don't get confused. In your course, you know what you have to write. You have heard the word in the class. So whether they give the spellings wrong or whatever, the way you see the scheduling algorithms, you know it is preemptive and non preemptive. Primitive, they print or whatever, I don't know. At one instance of time, it came primitive and non primitive. So, saw on the internet what is preemptive and what is non-preemptive, or just that? So write down first. You want to write preemptive or non-preemptive? If you understand non-preemptive, then preemptive will be so clear. It is that you grab a resource and then you release it when you have finished the work or you are switching to somewhere else. Okay, supposing you have taken a seat in the bus and you do not leave it till the time your bus stop comes. Or maybe like you've got a better seat, then only you leave that seat. Similarly, the CPU has been allocated a process. The process keeps the CPU until it is releasing CPU either by terminating or by switching to the waiting state. And preemptive, as the name suggests, are cooperating. They will preempt a process before it blocks or terminates in order to allow the CPU to work on another process. So I'll speak slowly, slowly. If you want to write, you can write. Which one should I tell first, preemptive or non preemptive? Okay, write down preemptive algorithm. Scheduler may preempt a process. Scheduler may preempt a process before it blocks or terminates in order to allocate CPU to another process. You can read out, or should I repeat if you have left somewhere? Repeat, please. Okay. Scheduler may preempt a process. Scheduler may preempt a process before it blocks or terminates in order to allocate CPU to another process. Now done. The other one is non-preemptive algorithm. Once CPU has been allocated to a process, comma, process keeps the CPU until it releases CPU either by terminating or by switching to waiting state. Got it, everyone? Okay, thank you. Still, I read it out. One CPU has been allocated to a process, comma. The process keeps the CPU until it is releasing CPU either by terminating or by switching to ready state. So now we will start the scheduling algorithms. First of which is FCFS. You have heard of this name before?
Yes, ma'am.
Okay, what is it?
Ma'am, the process which comes first in ready state will be first executed.
Yes. I'm not asking you the details to see from Google and answer. I'm just asking the full form of FCFS.
Oh, first come first, sir.
Yeah, beta. So this you have done in that data structures paper.
Yes, ma'am. In stack.
Okay. So this is the thing we have to do here, and you had correctly said the process which comes first shall be executed first. Okay. Others get it? The full form of FCFS? Children, please reply. Yes, ma'am. Thank you, Aditya. A process that requests the CPU first, you can write down a process that requests the CPU first is allocated the CPU first. जिसने पहले मांगा उसको पहले मिलेगा. For example, the following processes arrive in the order P1, P2, P3. There are three processes which are coming, and their execution time is written as burst time. The spellings are BURST. There is process P1 whose burst time is 24. Process P2, its burst time is 3 seconds or milliseconds. Whatever be the unit, we are not concerned. That will be given. Again, 3 time units. They can be printed in any form. You just have to be concerned that it is a process name. In your book, it's written like this, but in exams, it is written like this. It hardly matters to us. What we are concerned about is their burst times. Copied, everyone?
Yes, ma'am.
So ये हमारे प्रोसेसेस हैं और ये इनका बर्स्ट टाइम है. तो पहला वाले को कितना टाइम चाहिए? 24। 0 से स्टार्ट हुआ और इसने कितना टाइम लिया? 24 टाइम यूनिट्स। फिर नेक्स्ट प्रोसेस आया, उसने कितना टाइम लिया? 3 टाइम यूनिट्स। 20 24 प्लस 3, it runs up to 27 time units, and then another one comes, P3, and it executes for another 3 time units. So this is the Gantt chart that you will have to draw. You can all see.
Yes, ma'am.
Okay, you have to draw the Gantt chart first of all. Whatever is given to you, the number of processes, they will be given at what time they are entering the system, how much time they are taking to execute. So you will have to draw this Gantt chart. Had they arrived in the order, first of all, P2 had entered, followed by P3 would have entered, and then P1 would have come. So in that case, FCFS would have been like this. Clear? What happened?
Yes, ma'am.
Okay, good.
मैम
बताओ.
मैम डायग्राम में P3 पहले क्यों लिखा था?
अगर इस ऑर्डर में आए होते तो.
ओके
ओके. पहले
ओके
तो
मैम।
बनाया था हमने, P1 आया था, P2 और P3 सारे 0 टाइम पे आए थे. बट अगर इन्होंने ऑर्डर ऐसा दिया, जो पहले आएगा उसको पहले मिलेगा, आपको वो आगे लगाना पड़ेगा.
ओके मैम।
मैंने करके मैनिपुलेशन दिखाया था आपको कि अगर ऐसे हो जाए, जो पहले आएगा FCFS में, चाहे लंबा प्रोसेस को देना चाहिए ताकि वो कर करा के ख़त्म हो, ऐसा नहीं होगा. जो पहले आएगा उसको, छोटा हो बड़ा हो, उसको पहले मिलेगा.
मैम फिर इस हिसाब से तो P2 को पहले आना चाहिए था.
दोनों ही तो 3 ले रहे हैं. हाँ, P2 यस.
ओके मैम।
हाँ, P2 करेक्ट. कंट्रोल Z. P2 फिर P3 बिल्कुल ठीक है. पता नहीं कैसे मुझसे वो टाइप हो गया. Okay now, as per this, P2 and then P3 and then P1. Thank you for pointing out. Second algorithm is SJF, shortest job first. It selects the job with shortest expected processing time. Written the definition. शॉर्टेस्ट जॉब फर्स्ट क्या है? Written.
Yes, ma'am, written.
Thank you. It selects the job with shortest expected processing time. So this is the question example form we are doing. There's process 1 whose burst time is 6 time units. Process two's burst time is 8 time units. Process three's is 7 and process four's is 3. सबसे छोटा कौन सा है? P4
P4.
है ना? सबसे पहले इसको मिलेगा. कितना टाइम चाहिए इसको? 3 टाइम यूनिट्स. उसके बाद उससे नेक्स्ट बड़ा कौन सा है? P1 6 टाइम यूनिट्स. ये ना गैंट चार्ट बनाने ज़रूरी हैं, इसके थ्रू हमारे आगे सॉल्व होएगा. अब कौन सा है? P3. 9 + 7 16 टाइम यूनिट्स में ख़त्म होगा. और एक और प्रोसेस जो बचा है हमारा, कौन सा बचा है? P2 जिसका कि 8 है. Understood?
Yes, ma'am.
So today let's start with this numerical so that time is not wasted much. तो हमें ये 4 प्रोसेसेस दिए हुए हैं, ठीक है? इनके बर्स्ट टाइम दिए हुए हैं और अराइवल टाइम दिया हुआ है. प्रोसेस 1 का अराइवल टाइम है 1. प्रोसेस 2 का अराइवल टाइम है 0। प्रोसेस 3 का अराइवल टाइम है 2। और इसका क्या है 3। कॉपी दिस क्वेश्चन। इसका FCFS बनाओ। ड्रॉ।
Yes, ma'am.
एवरीवन।
Yes,
Yes,
जो
ma'am.
जो ध्यान दे रहे हैं। सबसे पहले कौन सा लगाया आपने?
P2
P2। कब से कब तक?
0 से 6.
ठीक है। नेक्स्ट बेटा।
P1
वो कब खत्म हुआ?
9 पे.
फिर
P3
ये कब खत्म हुआ?
12.
सबका यही बना है बच्चों? और
Yes, ma'am. Same.
लास्ट
yes,
कौन सा है? 4 ही बचा अब, है ना? 17 पे।
Yes, ma'am.
अब निकालो इसका जो क्वेश्चन मैंने सिखाया था पिछली बारी, ये टर्न अराउंड टाइम कैसे निकलेगा। ठीक है। आप लोग क्या करोगे? प्रोसेस 1 का देखो कैसे निकलेगा। हमें डायग्राम देखना होगा। प्रोसेस 1 कब खत्म हुआ है?
9 सेकंड पे।
9। ठीक है, तो यहाँ लिखेंगे 9 माइनस
1।
1। वेरी गुड। तो इसका कितना हो गया? 8, मतलब उसका अराइवल टाइम जो क्वेश्चन में आपको दिया होगा। पहला वाला आप डायग्राम से देखोगे अपने गैंट चार्ट से। 9 हमें कहाँ से मिला है? गैंट चार्ट में से देख के। और 1 हमें क्वेश्चन से मिला है। तो P2 का क्या होगा?
6 माइनस 0।
हाँ, 6 माइनस 0। तो उसका टर्न अराउंड टाइम क्या हो गया?
6।
P3 का भी निकालो और P4 का भी निकाल लो। P3 कब आया था? 2 पे। और ये आया था 3 पे। निकल आया सबका टर्न अराउंड टाइम। आगे कैसे निकालते हैं? तो एवरेज टर्न अराउंड टाइम इन सबको टोटल करके 4 से डिवाइड कर दो। एग्जाम में मांगा जाएगा एवरेज टर्न अराउंड टाइम। निकालो क्या हुआ है इनका।
नाइन पॉइंट फाइव।
जो भी है मैं नहीं कैलकुलेट कर रही, बाकी बच्चे आपस में कंफर्म कर दो।
यस मैम 9.5 है।
ठीक है, अब नेक्स्ट निकालो इसका वेटिंग टाइम। वेटिंग टाइम कैसे निकलेगा? टर्न अराउंड टाइम जो भी निकाला है माइनस बर्स्ट टाइम जो क्वेश्चन में दिया हुआ है। तो P1 का क्या है हमारा टर्न अराउंड टाइम? 8। और इसका बर्स्ट टाइम कितना दिया हुआ है क्वेश्चन में? 3। तो कितना आया इसका वेटिंग टाइम? फिर चुप हो गए।
5।
ठीक है, हाँ या ना बोलते रहो कि ठीक हो रहा है कि नहीं। फिर उसके बाद 10 आया था शायद। और इसका दिख रहा है 14 आया था। ठीक है, दिस इज देयर वेटिंग टाइम 5, 0, 7 एंड 9। इसी तरह से इसका एवरेज निकाल लो। एग्जाम में पूछा जाएगा एवरेज वेटिंग टाइम। निकाल लिया? निकल आया? 12 9 21 अपॉन 4। 5.25 आ गया सबका?
यस मैम।
ठीक है, तो सारे जितने भी हम एल्गोरिथम्स करेंगे, हमने FCFS कर लिया, SJF कर लिया, तो सब में ये आपको एग्जाम में पहले गैंट चार्ट बनाना होगा, फिर ये निकालना आएगा। लास्ट कर लेते हैं अब रिस्पॉन्स टाइम। ये कैसे निकलेगा? डायग्राम में से आप देखोगे टर्मिनेशन टाइम, और उसमें से माइनस करोगे सम ऑफ अराइवल टाइम प्लस बर्स्ट टाइम। तो पहले वाले का टर्मिनेशन टाइम क्या है? 9। अच्छा, और अराइवल और बर्स्ट टाइम का सम क्या है इसका? 4। तो इसका रिस्पॉन्स टाइम है 5। प्रोसेस 2 कब फिनिश हुआ है? 6 पर। और इन दोनों का सम क्या है? 0 + 6। तो इसका रिस्पॉन्स टाइम 0 आ गया। अब ठीक है, समझ आ गया? प्रोसेस 3 का 12, प्रोसेस 4 का क्या है? 17। 3 + 2 5। 5 + 3 8। हो गया?
यस मैम।
चलो आज इतना ही करते हैं, ठीक है? शुड आई स्टॉप शेयरिंग? Okay, then you can send your attendance. वाह,
Hello.
अब माइक को ऑफ कर गया रे। लेफ्ट मार।
फ्री फायर खेलेगा?
खेलेगा।